Okay. All right. Hi, I'm Geoff. I'm from the University of Alaska Fairbanks. I'm a geochemist, and on this cruise, I'm the chief scientist. And as the chief scientist, I have to deal with a lot of other issues that the other scientists don't have to. Mostly logistical issues, permitting issues, and just to be able to work in another country's waters, we have to fill out a bunch of forms. Everything from what we're doing, what we're collecting, and how we're going to preserve them, analyze them, and so on. And of course, the country of origin has the right to ask for samples, ask for data, and collect all that stuff. So as the chief scientist, I have to deal with a bunch of bureaucratic aspects, as well as try to keep all the different groups together and as one big happy family to make sure everyone gets their appropriate samples and that everyone can succeed. So while we have a variety of different groups on here doing having different emphasis on the same project, my specialty is in geochemistry. What I do is I use the fluid composition of water to understand how the water flows through the crust, what minerals it dissolves as it goes along the way, and then when it comes out, what minerals precipitate. So one of the things, like all the ore deposits on land that we get our copper, zinc, different metals like that, they used to be a hydrothermal system where, once again, the water flows through the crust, gets heated up, dissolves some minerals in one area, and then reprecipitates out the ore in a different area. And so this is very similar, except in this case, we're looking at a system that's very low temperature. It's only 10 or 20 degrees Celsius above bottom water. And so the reactions that take place are a little different than the reactions that take place at high temperature that actually form these ore deposits. So just understanding how that water goes through the crust is interesting, because it also, as it goes through the crust, it also ages the crust, and it changes the crust. Minerals precipitate, like calcium carbonate, forms veins in the rock, which means it cuts off permeability. Once you close up the little clogs here and there, water can't flow. And so trying to understand how the crust evolves, the minerals that react, and how that water flows is what I'm out here primarily for.